Hello guys, welcome to the channel. Today I'm gonna solve today's LeetCode daily challenge, uh, which is pseudo-palindromic paths in a binary tree. So let's read the problem. Given a binary tree where node values are digits from 1 to 9, a path in a binary tree is said to be pseudo-palindromic if at least one permutation of the node values in the path is a palindrome. So we need to return all the numbers, all the paths that are forming pseudo-palindromic from uh, root node, root node to leaf node. Okay, so let's understand the problem by given example. So let me turn on the tree visualizer. So as you can see, this is the tree. So what are the paths going from leaf node, root node to leaf node? That the values that are included in the first path is 233. So is it a palindrome or not? So let's see. So our tree is suppose like this: 2, uh, then 3, uh, then 3, and okay, so 3 as one another right child, and 1 and 1. Okay, so this is the tree, and we want to find the what are the paths going from root node to leaf node having values as a palindrome, values as a palindrome. Okay, so the first path is 233 going from root node 2 up to leaf node 3. Okay, so what are the values coming in this path? The values are 2, 3 and 3. So let's find out all the permutation of this sequence. So that will be the another permutation of this sequence is 3, 2 and 3. The another one will be 3, 3 and 2. So as you can see, uh, first and third is not the palindrome, okay, but the middle one, the second one, the second permutation of this sequence is a palindrome. Okay, so likewise, another path will be 231. Okay, 231. So let's write all the permutations. So it has the three different values. So the number of permutations will be 3 factorial, which is 6. Uh, Let me write that: 213, 321, 312, 123 and 132. Okay, so if we try to find out what are the permutations that are palindrome in this sequence, so we can't find any permutation that form a palindrome. Okay, so this path has not any permutation that can be a palindrome. Okay, so the next path is 211, 211. Okay, 211. So let's find out the all the permutation of this sequence. So that will be 1, 2, 1, 211 itself, and 1, 1, 2. Okay, as you can see, the first one is forming a palindrome. Okay, so we have found a permutation of this sequence that is 1 to 1, that is a palindrome. Okay, so likewise, we have to find all the paths, the number of paths uh, of which any one permutation should be a palindrome. Okay, uh, so let's visualize this tree. Okay, so as you can see, uh, we have already found that this is a palindrome. Okay, it is, yeah, this is 1 to 1 is a palindrome. So this is forming a palindrome. But uh, if we uh, if we try to find the permutation of this path 2 1 3, as you can see, let me write down, yeah, this path 2 1 3 1, so it is not forming any palindrome. Okay, why? Because uh, as you can as you know, the property of the palindrome is, if the number of elements in, suppose this is palindrome. Why? Because the all the number of sequence in this the number of elements in this sequence is odd. Like if we form it, if we save it in an array, so there will be three elements. Okay, 0 1 2. So there are three elements. Okay, and if there are odd number of elements in an array, and we need to say that this array is a palindrome or not. So we know that middle element should be middle element should be appears only once. Okay, middle element should be appears only once for this corresponding position. uh, what I mean to say that, if there are there can be many twos, but the middle one, the number of twos will be odd. Okay, the number of twos will be odd. So the middle element, the frequency of the middle element will be odd if the elements of in the array that we are trying to say that it is a palindrome or not, the frequency of the middle element should be odd. Okay, suppose if the elements in the array is even, like we have given here 2 1 2 1 3 1. Okay, so no so if we try to uh, permute this sequence, so what uh, no matter how can I try, there will not be any permutation that can that we can say this is a palindrome. Okay, because in order to in the even number of elements, there should be all the elements, all the frequency of all the elements should be odd. Okay, suppose if there are array that has even number of elements, and we need to find the whether this array is palindrome or not. So what we need to do, we need to have all the elements with even number of frequency. Like if we have 1 2 2 1. Okay, so this is forming a palindrome. This we can say this is a palindrome, because the element 2 has even number of frequency. The one is also having even number of frequency. Okay, yeah. So this is the condition for palindrome we need to find. Okay, so how we will solve this problem? So I have two approaches to solve this problem. I have already solved this problem, so I will just discuss those two approaches. And uh, okay, so uh, let me discuss the first approach. First approach. Okay, so as you can see, we need to traverse the tree. Okay, so we will be using DFS. Okay, and um, if as soon as we will maintain an array. As you can see, the constraint of the node value is only from 1 to 9. Okay, so what we can do, as we have seen already, that we need to just calculate the frequency of every element that is appearing in the path. And if the elements number of elements in the array in the path is odd, then there should be only one element that has odd number of frequency. Okay, and if the values that are coming in the path has even number, okay, the number of elements that are coming in the path is even, then no such element should be there that has odd number of frequency. Okay, so this is the condition. So what we can do, we can maintain an array of size 10, okay, and we will store the frequency of each element in that array, okay. So uh, as soon as we reach the leaf node, okay, so we will check the array uh, if the array elements are, if the number of elements present in the array is odd or even. If it is odd, then we need to have the only one element that has odd number of frequency, okay. And if the number of elements in the array is even, number of elements in the sense the number of elements that are coming in the path, the number of elements coming in the path is even, then there should not be any element that has odd number of frequency, okay. So that is the logic. And first code this log first we will code this logic and then discuss the another logic, okay. So what we will do, uh, I will just create uh, an what we can say, an variable that will that will hold the count of the number of paths that is a pseudo palindromic path, okay. And what we will do, we will call a dfs function, and it will hold the parameter as root and one array. I will be using vector for simplicity, okay. Yeah, so, and it will not return anything, okay. So let's keep it as a void. So let's write the base case. So suppose if we have if there isn't any way to go the left children of the node, so we will just return, okay. So if root is equals to null, okay, null, so we will just return, we won't do anything, okay. Now um uh, so we need to we will be having a vector of 10 size, okay. So at each point uh, at each point while we traversing the node, while we traversing the root node, we will count the frequency of that value of the root node, okay. uh, we will store the frequency in the array, in the vector, okay. So we will just do this, and after doing this we will check if this node is a leaf node or not. So how we can check this is a leaf node or not? We will do it if the left children of the root is null, and if the right children of the root is also null, okay. So we will check if the path that so we have found the leaf node, okay. This is the condition that check whether the root is leaf node or not, okay. So if this condition is true, then we need to just check the whole array and find the we need to just find the condition that is satisfying or not for saying for saying that it is a palindrome or not, okay. So we will just do int number of odd elements, number of odd frequency element, and number of even frequency element, and we will be having total for calculating that how many elements are there in the array. Okay, so we will just traverse the array. um, the size is fixed, which is 10. So we will just traverse it. Suppose if okay, total plus equals to vi. If so we are here, we are just counting the what are, how many numbers are have odd frequencies, and here we just counting how many numbers have even frequency. Okay, so if vi uh, is odd, if the number of frequency of vi is odd, then we will just update the odd by incrementing it. Else what we do, uh, we increment the even. Okay, number of even elements that has even frequency, number of element that has even frequency. Okay, so then after traversing whole array, we will just check if the total is odd. That means we have odd number of elements in our path. Okay, if this is odd, and our number of odd elements is also number of odd elements is 1. Okay, so by to hold this the property of the palindrome, there should be only one element, that is a middle element, that should have the uh, odd number of frequency. Okay, that is one condition. So there can be another condition, that if the total number of total elements in the path is even, then what we need to do, if total uh, total is odd, oh sorry, even. Okay, if total is even and number of, so in that case number of odd should be 0. Okay, so number of odd should be 0, then only the condition of having palindrome palindrome pseudo-palindromic paths can be true. Okay, so in that case, uh, wait, yeah, so this is the condition. If that holds true, then what we need to do, we will just increment the overall result. Okay, and so if this is the leaf node. Okay, this is the leaf node. So after doing this, we will just call the recursive function for left subtree of the node. Okay, and we will call it for right subtree of node. Okay, so after coming after traversing all left subtree and right subtree, we will just backtrack uh, the value that we have increment the frequency that we have implemented in our result, because as you can see here, we have passed our vector as in pass by reference. Okay, so we need to do this. uh, yeah, so that's it. We just call it this dfs function from our main function, which is pseudo-palindromic path. So let me create one vector of 10 size, which will hold all the values as 0 initially, and we will just call the function root dfs function with root node and vector v. After doing this, we will just return the our result. Okay, so let me just run this quickly. What it says. Okay, now this is an typing mistake, so let me fix that. Okay. Yeah, so as you can see, we have got the output as 2. So let me run it for all the test cases, for example test cases. Okay, so let's submit this. Okay, so as you can see, it has I have solved this problem, but it is running very slow. This solution is running very slow. Look, actually, the time complexity of this solution will be what the time complexity. Okay, what? Yeah. So the time complexity will be O of n, which is n is number of nodes, plus every time we are go, we have reached to leaf node, and then we are doing the traversing of the whole array, which is size of 10. So the extra factor that is going to be there, 10 into the number of leaf node. So 10 into number of leaf node. Okay, so this will be the complexity of this solution. Okay, yeah. So let's discuss the another approach, which is quite efficient compared to this one. Uh, in this second approach, what we will do, we will use the bit manipulation to solve this problem. Okay. Uh, so let's see how we can use that. So let me just quickly explain that. Um, okay. So wait. Wait a minute. Oh God, why it is not? Uh, yeah. Oh shit. Okay, so let's discuss the second approach. So how we can use the bit manipulation here? So, okay, so the main concept, the main approach will be there when we check how to when we check how we can efficiently check the elements that are present in the path is palindrome or not. Okay, so as we have already seen that we need to just see the frequency of the element. Okay, if the frequency of the element is if the number of element present in the path is odd, then we need to have only one element that has odd frequency. Okay, but if the elements are even, the number of elements are even, then we don't need to have, we will be having only uh, even number of frequency, or elements having even number of frequency. Okay, so so uh, there is we can use XOR property to solve this problem. Okay, so how will we using XOR property? So as you can as uh, I assuming that you have no idea about the XOR property, that XOR of the number of if we do the XOR of elements by its XOR of two same elements, then the result will be 0. Okay, okay, so XOR of two elements will be 0, and XOR of element with 0 is uh, it will generate the original number. Okay, so uh, we will use the XOR property. Like, let me explain a bit more about this. So we will use the number that are given here, that is 1 to 9. Okay, so we will use it as a power of 2. Okay, so how we can use how will we can use this power of 2 and solve this problem. So suppose we have given this sequence, right? Like 2 1 1. Okay, we have given sequence 2 1 1. We have been given the sequence. Okay, so if we generate the power of 2 of these elements, so what will be the answer? The answer will be 2 to the power 2, which is 4, 2 to the power 1, which is 2, 2 to the power 1, which is 2. Okay, so if we do the XOR of this, we do if we try to visualize the binary representation of this, so the binary representation of 4 is 1 0 0, and the binary representation of 2 is 1 0. This will be 1. So if we do the XOR of this whole thing, the answer would be 4 only, because the if we do the XOR of 2 and 2, the answer will be 0. Okay, so let's do this. Suppose and there is one more property. The XOR property is cumulative. Okay, so if we do this XOR of 2 and 4, and then we do the XOR of 2, the result will be same. Okay, so the result will be same with this. If we do this, both the result will be same. Okay, so the XOR property is cumulative. So the XOR of 2 and 2 will be 0, and the XOR of 4 and 0 will be 4. Sorry, XOR of 4 and 0 will be 4. So as you can see, if we have odd number of, if we have the sequence, that is the sequence, and one permutation will be palindrome, then in the end we will be getting only one element that has odd number of frequency. And if we uh, if we try to visualize it, if we get only one element with odd number of frequency, so in the end we will be getting the power of 2. Okay, the answer is a power as a power of 2. Okay, so we need to just check if the answer is a power of 2 or not. If it is a power of 2, then we can already we can if it is a power of 2, then we need to just find that it is a power of 2 or not. If it is, then the sequence, the one permutation of this sequence will be palindrome. Okay, so that's the idea here. Okay, suppose we will be having a number like this: 1 3 3 3 1. So we will be just converting these numbers into the power of 2. What will be the number? The numbers will be 2 to the power 1, which is 2, 2 to the power 3, which is 8, 2 to the power 3, which is 8, 2 to the power 3, which is 8, and then 2. And then we will, if we do the XOR of this whole sequence, what we will get? The XOR of 2 and 2 will be 0. XOR of 8 and 8 will be 0. Okay, so in the end we will get XOR of 8 and 0, which will give us a 8. Okay, so this is the power of 2. So in the end we need to just check if the number, that is if the XOR of whole sequence is power of 2 or not. If it is not, then the sequence is not a well, the sequence hasn't any permutation that can be a palindrome. Okay, if it is, then the sequence has a permutation that is a palindrome. Okay, so that is the whole idea. Okay, so just uh, we just code it quickly. Okay. We will be having dfs function and one tree node, uh, root, and one number. Okay. Why keep it, so we will be holding one number for that will keep track of the XOR of whole sequence. Okay. So the number, let's say t. Okay. If it is a root is null, we will just say we will just return from here. Okay. And after this we will just calculate the XOR. Okay. So how will we calculate the XOR? XOR is the XOR of the sequence. Okay. So we will just we will just do the XOR of the current node value with the our with the value that is for that has t. Okay, that we have in the t variable t. So that will be and one more thing, we can use power function also to find the uh, power of 2, but there is one shortcut that we can use, that is binary shift operation, bit shift operation, that will calculate the power of 2 quickly. Okay. So power of 2 of node value, so root value, well. Okay. And then what we need to do, if the root if the node is leaf, then we will just check the whether the t value is a power of 2 or not. Okay. Root right should be also 0, null, sorry. So if that is the case, then okay, so I have forgot to assign the result variable, that will be 0 initially. So if that is the case, then there is one more property that you can with that you can quickly find the power of 2 in O of 1. So the binary representation of power of 2 is what? If we have 8, so the binary representation will be 100 okay. So in order to find that it is a power of 2 or not, what we can do, we can just, if we just take the power of 2 minus 1, that will be 7, and the binary representation of 7 is what? 0 1 1 1. Okay. So if we do the binary end operation, bitwise end operation of these two numbers, then we will be getting 0 0 0. Okay. That is nothing but a 0 in decimal format. So if the number is power of 2 and we do the binary bitwise end operator with a number minus 1, then we will get 0. If this is true, then the number is a power of, okay. So just we do this. Okay. So what we do, if the bitwise end operator of t and t minus 1 is 0, we will just update our result. Okay. Yeah. And we will call this for our uh, left subtree and right subtree. Okay. um, I guess that will work. Let's run this. Uh, what is the problem? Okay, so I haven't assigned the, I haven't called the, what a silly mistake. Um, okay, so yeah, as you can see, uh, output is coming as expected. Yeah, so that's it. Uh, so that's it for today. If you guys really like this, so you can subscribe to the channel, and I will be posting these type of contents like LeetCode daily challenges and some programming contents. So yeah, thank you for this listening to me. Yeah.